Now we are going to look at the topic context-free grammar to push-down automata conversion. In rule 1, for each non-terminal capital A in CFG, del of q comma epsilon capital A equal to q comma B. If A tends to B is a production of context-free grammar. In this line, del of q comma epsilon capital A, this is the transition function of the push-down automata. It means when PDA is in state Q, read no input denoted by epsilon and see non-terminal capital A on top of the stack. The right hand side of the production Q comma capital B, the PDA stay in the same state Q and replaces capital A on the stack with string capital B. If A tends to B is a production of context-free grammar, this transition is applied only if there exists a production rule in the context-free grammar that writes A as capital B. Next rule, for each terminal small a in CFG, then del of q comma AA equal to q comma epsilon if A belongs to T in CFG. Here del of q comma AA, the PDA is in state Q. Read terminal small a from the input string and find the same terminal small a on the top of the stack. The right side of the production q comma epsilon, the PDA moves forward by consuming small a from the input, popping small a from the stack. Stay in the same state Q. If A belongs to T in context-free grammar, this rule is valid only if A is a terminal symbol defined in the grammar. The first step models the replacement of non-terminal symbols using production rules, just like how derivation works in a context-free grammar. The second step ensures the PDA matches and removes terminal symbols from both the input and the stack, simulating successful passing of input symbol. Overall, the PDA starts with the start symbol of the CFG pushed onto the stack. Then expands non-terminal using step 1, matches and consumes terminal using step 2. If the input is fully consumed and the stack is empty, the PDA accepts the string just like the string would be derived in the context-free grammar. Now let us see a problem of converting a context-free grammar to a push-down automata that accepts the language by empty stack. The given grammar is S tends to 0, S1 or capital A, then A tends to 1 followed by capital A 0 or capital S or epsilon. In this production, capital S and A are non-terminal. Terminals are going to be 0, 1, epsilon. In step 1, transition function of PDA, for a PDA that accepts by empty stack, the general category is push the start symbol capital S on the stack initially, replaces non-terminals on the top of the stack using productions, match input symbol with the terminal symbol on the top of the stack and pop them. Then accept when both input and stack are empty. For non-terminal S comma A, expanding productions del of q comma epsilon capital S. These transitions represent applying the production rule. The PDA stay in the same state Q and replacing capital S with 0 S1 or capital A. Then you will get q comma 0 S1 q comma A. Next, del of q comma epsilon capital A. Here PDA stay in the same state Q, replacing capital A with 1A0 or capital S or epsilon. Then you will get q comma 1A0, q comma S, q comma epsilon. Next, for terminals 0, 1, epsilon, we have 3 terminal symbols. Then del of q comma 0, 0. Read a 0 from input when 0 is on top of the stack and pop it. Then you will get q comma epsilon. Next terminal symbol 1, del of q comma 1, read a 1 from input when 1 is on top of the stack and pop it. Then you will get q comma epsilon. Last terminal symbol epsilon, del of q comma epsilon, do nothing, used for empty stack acceptance condition. Then you will get q comma epsilon. The PDA accepts the language generated by the given CFG by empty stack It means process the input completely and end with an empty stack. It indicating successful acceptance. Coming to second step, instantaneous description of a PDA processing the string W equal to 0101 and demonstrating that it is accepted by empty stack. Let input string W equal to 0101, initial configuration del of state name Q, string 0101, comma, starting state capital S. Then turnstile notation del of state name Q, comma, string 0101, apply production. Instead of S, substitute 0S1 or A. Here by replacing capital S, 0S1, because input start from 0101. Match terminal 0 and pop 0 from stack. Then you will get del of Q, 101, S1. Apply the production by replacing capital S, substitute capital A. Here you write capital A. Then you will get the configuration Q, 101, A1. Here input start from 101. By replacing capital A, substitute 1A0 or S or epsilon. But input start from 1. Here you write 1A0. Then you will get a del of Q, 101, 1A0. Match 1 and pop 1. Then you will get a del of Q, 01, A01. By replacing capital A, substitute epsilon. Here you write epsilon. After that, del of Q, 01, 01. Then match terminal 0 and pop 0. You will get del of Q, 1. Again match terminal 1 and pop 1. Finally, you will get del of Q, epsilon. Now both input and stack are empty, that is accepted. The string 0101 is accepted by the PDA by empty stack. I hope you all understood the concept of context-free grammar to pushdown automata conversion. If you have any doubts, feel free to leave a comment in the section below. Don't forget to subscribe to my channel and press the bell icon for more videos. Thank you for watching.